modern float glass line. They produce more than 1 million tons of float glass worldwide every year. Invented by Pilkington, the float glass process quickly became the universal method for producing high-quality flat glass for the building and automotive industries. Today, it also makes glass that insulates, glass that reflects, glass for use in electronics, in defense, even glass that produces electricity. And each line can produce 700 tons of glass a day, every day, for up to 10 years. Glassmaking uses some of the Earth's most abundant raw materials. The main constituent is sand, accounting for 60% of what is called the batch. Lime and dolomite are added to assist the weathering properties of the finished glass, while soda and sulfate lower the temperature at which sand will melt. But glass itself is also an important ingredient. Broken glass, called cullet, is recovered from the manufacturing process and then crushed before being added to the batch. This further accelerates the melting process and reduces the amount of energy required for melting by up to 1/5. All raw materials are rigorously checked to ensure the purity of the batch. It's then fed automatically into the filling end of a furnace with a capacity of 1,800 tons. Natural gas, burned in preheated combustion air, then heats the batch up to a temperature that reaches 1,600 degrees centigrade. New technology invented by Pilkington ensures that the majority of emissions from the process, including those that might cause acid rain, are either trapped or converted to harmless nitrogen. Processes within the furnaces are managed from the control room to ensure that the glass is homogeneous and free of bubbles. Inside the furnace, heat is applied from alternate sides in 20-minute cycles. This assists fuel efficiency by ensuring that combustion takes place in the presence of preheated air. The glass leaves the conditioning end of the melting zone at a temperature of 1,100 degrees centigrade through a narrow canal, from where it passes to the heart of the process, a bath of molten tin. Here the glass spreads out, following the perfect flatness of the tin, so that the upper and lower surfaces of the glass remain absolutely flat and parallel. The glass is made thicker by confining its initial outward spread over the tin. To make thinner glass, the top rollers controlling the width of the glass are speeded up to produce a gentle stretching action. A controlled atmosphere of hydrogen and nitrogen within the bath prevents the tin from oxidizing. When it emerges from the tin bath, the glass is sufficiently hard not to be marked by the conveyor rollers. special properties, including the ability to reflect heat, can be imparted by applying an extremely thin metallic layer to the glass while it's still hot. Pilkington K-glass, produced in this way, increases the efficiency of double glazing by as much as 50%. The glass now enters the annealing layer, where any stresses are removed by a controlled cooling process. In a length of 250 meters, the glass is taken from 600 degrees centigrade down to room temperature. At this stage, the glass is perfect. Only the indentations left by the top rollers remain to be scored, ready for removal. This takes place after the glass has been cut and snapped to a predetermined size. Glass removed in this way is carried away on conveyors to be reintroduced at the beginning of the melting process. After passing through the automatic handling stages, customers' orders, which might involve a range of thicknesses and sizes, as well as special coatings, are held in the warehouse. Before being transferred to float liners for safe delivery to customers. Today, float glass is used wherever the demand is for clarity and precision, adding beauty, comfort, and security to the world's buildings, with ever higher standards of energy conservation. Glass systems bring safety and styling to cars, with increasing sophistication and new systems built into the glass. Float glass is also extending its usefulness to new and emerging technologies in electronics and solar power. We are just beginning to exploit its versatility.